All right. We're going to look at some more graphs here and determine where the graphs are greater than or equal to 0, whatever.
Whatever's asking
More
us.
fun stuff.
Investigate the graph of x squared plus 7 times 2x squared plus 1 and determine where the graph is greater than 0, greater than or equal to 0, less than or equal to 0.
It doesn't say analytically or graphically though, but there's a picture right there.
Yeah, so we could get this by putting this into our calculator, and if you look, this looks greater than 0 to me.
I'm pretty sure
the whole time.
there's no less than 0 there. I mean, the
Okay.
little red line never crosses the x-axis.
So would we do greater than 0, and we would say like negative infinity to positive infinity?
I mean, you said that like it's a question. It's more of a statement. That
Oh,
one.
okay. And then greater than or equal to 0.
Same place, actually, because
It's still greater than or equal to 0 at all those places.
matches
Even
that.
though it's never equal to, that's fine. It's still greater than or
right,
equal to.
it satisfies one of those two conditions.
Less than 0.
Empty set on that, or however you want to say it.
None.
Not possible. Not none.
Or
like
the
that,
empty
none.
set you do with the 0 with the line through it.
Yeah.
Less than or equal to 0.
Yeah, same thing.
Same thing.
All right.
That was a fun one. Okay,
Pretty much
now how about
empty.
this one? X
Hey.
squared minus 3x plus 3 times 2x plus 5 squared. Where is the graph greater than 0?
I sense some factoring in our future.
Really?
Yeah, because don't we want to figure out exactly where that crosses the x-axis there? Because
It should cross at negative 5 halves. But that's not what that is.
I mean,
no, that is. That's a negative 2 and a negative 3.
Negative
This-
2 and a
This
half.
0 is this 0 right here.
Where it's bouncing.
So 2x plus 5 equals 0, that's negative 5 halves. This other one doesn't actually factor because look, it just comes down and at some imaginary point apparently bounces.
Totally
if that's
imaginary.
even a real thing.
Yeah, I don't even know what you just said.
Negative 5
It's crazy.
halves. Okay, so where it's greater than 0 is, well, from negative infinity until we get to negative 5
But
halves.
you can't include negative 5 halves because
it's 0.
it's actually a 0 there, and we don't want the 0 on this
Not on
first
this one. Negative 5 halves to positive infinity. But greater than or equal to 0 would be the whole shebang.
Whoa.
From
Why
negative
is that?
infinity to infinity. Because now we can include that missing point that we had. So if we
Gotcha.
fill in this hole right here in our interval notation, that's negative infinity to positive
Right.
infinity.
Now, what if I wrote it from negative infinity to 5 halves with a bracket, and then from 5 halves with a bracket to positive infinity?
Technically, I guess that would be right, but that'd be silly.
I agree. Okay.
Less than 0.
Nah.
Nothing is less than 0 because we have this 0 here, but nothing is underneath our x-axis. So none, or you could say the empty set, and then less than or equal to 0.
5 halves, negative 5 halves.
Only negative 5 halves. So that'd be like a x equals negative 5 halves kind of situation. That's the only value that's less than or equal to 0 because that's the only value that's equal to 0.
Yes.